Hi everyone, my name is Caleb and I'll be introducing our project and providing an overview of its purpose and significance. For our overview, as shown here, our project dives into the relationship between greenhouse gas emissions and the growing intensity of natural disasters. By using MATLAB as a powerful tool for analyzing and visualizing data, we've worked to uncover meaningful insights about the impact of human activities on the climate. Specifically, our focus is on understanding how emissions are contributing to more frequent and severe climate hazards. This research really shows why it's important to take action now. The link between greenhouse gas emissions and natural disasters are obvious. Emissions are going up and the disasters are getting worse. That's why we need to step up and do something about it. And our goal with this project is to help people understand these problems better and think about ways of how we can make a difference. For our background information, we have Goal 13, which is the climate action, and which is one of the big goals of the 2030 agenda. It's all about fighting climate change and dealing with its effects and building resilience, cutting emissions, and making sure climate change is included in national plans. While Target 13.1 focuses on quick actions to save lives during disasters, and Target 13.2 is about making long-term changes to address the root cause of climate change. For our methods and algorithms, our program starts by letting the user pick a country that they want to focus on. Once that is done, the data is loaded and filtered so then we can analyze it. And from there, MATLAB creates visualizations to show trends in greenhouse gas emissions and how they're linked to deaths caused by natural disasters. Using MATLAB really helps us handle large data sets and make complex information easier to understand. By combining data analysis and visualizations, our program helps connect the dots between human activity and the impact on climate. Now I'm going to hand it over to Ian, who will explain the logic behind our code and is going to walk you through the demonstration.
I'm briefly going to run through the logic of our climate change code. It first starts with an fprintf and gives you a short intro on the code, and then it will prompt you to take a 5-question quiz. It then will input the tables so it can read them later, and then it will start a while loop. Basically, it will ask you a bunch of questions, and then at the end, it will prompt you, would you like to finalize your answers or do you want to return? If you choose to return, it will send you back here. Then it asks, would you like to finalize your design? You can either choose to break the while loop or it can send you back and you can choose those things again. Once you've chosen, it will input the variables and then graph them. This is a very important line right here. This checks in case you entered a country incorrectly, like you made a spelling mistake, or if the country does not exist in the data set that we have. So if that's the case, it will give you this prompt, and this code is also reused here to prevent the bar graph from returning an error. Then it will plot the disasters, and it can change the data set it's pulling from based on your previous inputs. It'll give you a short little summary of how this affects the goal for GHG, which is greenhouse gases, and it will also tell you about natural disasters. This is the demonstration for our project code. It prompts us to take a 5-question true or false quiz. We can input 1 for true and 0 for false. When we finish the quiz, it gives us a score. Now it's going to ask us for the country we want to select. We'll do Australia, and then we can choose between a bar graph or a line graph. We'll do bar graph. And then we get to evaluate methods of disasters in select your country. We can either do death rate, injury rate, or homelessness rate. Let's do death rate for Australia, and then this is the United States. We can choose injury rate for the United States. You can finalize your selection or 0 to redo. We do not want to redo, so we'll hit 1 to finalize our selection. It spits out a graph of the greenhouse gases for Australia versus the United States. The Australia is the blue graphs at the bottom, and the United States is the very large orange graphs. This is in kilotons of CO2. It then shows us the Australia versus United States disaster rates, and this is Australia's death rate versus the United States injury rate. So Australia is in blue and the United States is in orange. So this program, you can run through it again and get a couple different graphs. This can be a line graph. This could be something like Australia injury rate versus US death rate. There's a lot of options. Notably, it also has error protection against inputting the wrong country. So if you input a country that doesn't exist, like you misspell it, or a country that the data doesn't have, the program does not crash.
Thank you. Hi, Caleb. I'm Hasiel, and I'll be providing the conclusion for this project. First off, results and key findings. As you can see, the line chart demonstrates trends in greenhouse emission for countries the user has selected, of course, with the selected available data. While the bar chart visualizes the disaster-related fatalities over time, together they visualize the relationship between emissions and climate change impact aligning with the UNNC Goal 13 by underscoring the need for global action. The future steps needed to be taken to combat climate change globally and its impacts are 1. To implement stricter and effective policies that will not only decrease greenhouse emissions, but also make resilient infrastructure that will combat the rapid pace of climate change. 2. Further improve and work on solutions that would help reduce greenhouse emissions and already established solutions. And 3. Adopt eco-friendly practices that will help reduce greenhouse emissions and wasteful use of energy, as well as waste. The key takeaways of this project are to note that climate change is not just an environmental issue, but a humanitarian, an economic crisis that requires immediate action. The fight against climate change requires collective effort from engineers, policymakers, and individuals. We all must work together to secure a sustainable future for all of us.